Hi, welcome to the video guys. My name is Pushpinder Gill and today we are going to do compound interest 2, right? So in this video we're going to be learning how to adjust for installments when it comes to compound interest, right? So before we get started, this would be the web address, that is the perfect-scores.com, where you can explore more about us. This would be our Facebook page to give us a valuable like, and this would be the email address, that is perfectscores89@gmail.com, to give me your valuable feedback, right? In case you want to contact me, you can contact me through this email address. So let's go ahead and get started, guys. So now today we are going to do, in this video we're going to learn how to adjust for compound interest, how to adjust for installments. Now let's suppose if I say that I take I take a loan of $100 from you, right? So that's something acts as a principal. So suppose you watched the first video on compound interest, you're already through with the basics of compound interest before you learn this concept here. Now let's say that you get a principal of $100, which you plan to pay me throughout the time, right? So let's suppose you plan to pay me, and the compound interest, the rate of interest is actually equal to 10%. And let's suppose you plan to pay me an installment of $I every year, and that is something that you're going to do, let's say, for a period of 2 years. So how would the equation set up? How would we have a balance in terms of payments? Now understand this. Let's suppose a $50 payment today is more worth than a $50 payment tomorrow. Why is that? Because a $50 payment done today is I'm giving you $50 as well, plus I'm already giving you the interest that I can earn on $50 by giving this $50 tomorrow. So this is something that we have to adjust. We have to adjust for interest in prepayments, right? So we have to adjust for interest in my prepayment. So let's suppose I take a loan of $100 and I pay 10%, and I give $I in installment every year. So the first, and what am I supposed to give back to you? I'm supposed to give back to you 100 into 1.1 raised to the power 2. This is the amount that I'm supposed to give back to you if I take $100 loan from you and at a 10% rate of interest. So this is something that I'm supposed to give you back. Now that would be equal to my first installment, that is going to be for $I. But hold on, this first installment I'm actually giving you right now. What if I had given you this at the end of the period? Then I could have earned an interest of 10% myself. So this $I, I'm going to give you $I, but I'm actually going to give you $I into the 10% interest of it as well. So the $I which I gave you at the end of the first year is going to come to this at the end of the second year. Plus at the end of the second year I give you $I again. So I have this equation in front of me which is actually balanced here. Rather than me telling you that I pay you $50 first and then $50 second, or whatever, I just divide this by 2, that is not going to happen. Now why is that? Because the dollar which I pay you, so this is the total payback time, the dollars that I pay you here have to be adjusted for interest throughout the year. Because had I given you these $I at the end, I could have earned 10% interest myself. So this is how you balance your equation. So I suppose everyone is understanding what I'm trying to say here. When it comes to installments, this is how you balance your installments. Whatever you pay before, you got to adjust that for interest. The value of this $I is more than the value of this $I, and that is by a factor of this number. Now let's go ahead and move forward, and I'm just going to get to some questions here. Now this question says that a man borrowed a certain sum of money and paid it back in 2 years in 2 equal installments, right? So if the rate of interest was 4% per annum, if he paid $676 annually, what is the sum that he borrowed? Let's suppose that the sum he borrowed is equal to P dollars, right? Let's suppose he invested P dollars. So P, what is the amount that he is supposed to give back? The amount that he is supposed to give back is equal to P into 1.04 raised to the power 2. Why? Because it's a 4% compound interest and it's for a period of 2 years. So this is the amount that he is supposed to give back. And he pays $676 in the front year, in the first year, and $676 in the last year. But these $676 are not going to be equivalent to these $676 because they will have to be adjusted for interest again, right? So they would be earning a 1 year period interest. So this is what the equation I have. Now I have a balance of power both sides. So what do I need to do is I just need to get the value of P. So if I try to solve from here, P is going to be equal to 676 into 1.04 plus 676 divided by 1.04 raised to the power 2. So if I take 676 common out of here, I'm going to get 1.04 plus 1 divided by 1.04 whole square. This is going to be equal to 676 into 2.04 divided by 1.04 whole square, right? So this is how it's going to be. And if I try to calculate that, this is going to be 676 into 204 divided by 104 into 104 into 100, right? So all I got to do is just calculate this up. If I try to calculate it, that is, if I just try to calculate it, that is 676 into 204 into 100, and I've got to divide that by 104 and again by 104. So yes, my answer is going to be $1275, right? So I'm gonna skip the calculation here, something that is really doable, right? So suppose you're understanding what I'm trying to say here. This is how you adjust for installments. The $676 that I paid here were worth more than $676 that I'm going to pay at the end, because I could also have earned a 4% interest on these $676. So I suppose you're understanding what I'm trying to say here. Let's move forward to the next question. Okay, so the question says that a loan of $4641 is to be paid back in 4 equal installments, and the interest compounded yearly at 10%. Find the value of each installment. So it's an annual installment. So the 4641, so it's a $4641 rate of interest, and I'm paying it for 4 years at 10% yearly. So it's going to be 1.1 raised to the power 4. So this is my amount that I'm supposed to pay back. That would be equal to, let's suppose that the investment that I'm making is X dollars. The installment that I'm paying is X dollars. So the first installment that I pay would be equivalent to, I'm going to start from the last installment. The last installment would be equivalent to X dollars. But the second last installment that I'm going to pay have to be adjusted for interest. That is, it's going to be 10% more than the last installment, because the rate of interest is 10%. So I've got to take care of the 10% here. Then again, the third installment is going to be 1.1 raised to the power 2, because it has to be compounded for 2 years. And the first installment is going to be 1.1 raised to the power 3. So this is how you balance your equation up. And now all you got to do is you got to get the answer. So 4641 into 1.1 raised to the power 4. I'm going to take x common out of here. So this is going to be 1.331. This is going to be 1.21. And this is going to be 1.1. And this is going to be 1. So if I try and calculate that, that is going to be 4641 into 1.1 raised to the power 4 divided by 1.331 plus 1.21 plus 1.1 plus 1. So that is gonna be 4.641, which is gonna amount to, so this is gonna cut at 1000, 10 to the power 3. So it's 10 to the power 3 into 14641, and I've got 4, 1, 2, 3, 4. So my answer is gonna be $1464.1, which is nothing but my answer, option A. So suppose you're understanding my point over here, guys. The only thing that you have to set up is this. That is you got to balance your equations on both the sides, right? So suppose you're understanding this question here. Moving forward to the next one. So the question over here says that a sum of 16,400 is to be paid back in 2 equal annual installments, allowing 5% compound interest. Find the annual payment. So I would like you to go ahead and try this question all by yourself, and then we're going to do this question. Okay, let's go ahead and do this question, guys. So 16400 is to be paid back at 5% rate of interest for a period of 2 years. Let's suppose that the investment is X dollars. So and again it is X dollars, but the first X dollars has to be compounded for a 5% rate of interest, right? Bingo, nothing like it. So 16,400 is gonna be 1.05 whole square. Is if I take this X common, I'm gonna have 1.05 plus 1. Now this is nothing gonna be X into 2.05, and I'm gonna have this to be the same thing. Similarly, X is gonna be 16,400 into 1.05 squared divided by 2.05. So if I try and calculate that, I think 16,400 and 2.05 are gonna have something in common, right? So this is gonna be exactly 8 times of this, that is 8,000. And if I multiply by that by 1.04 and again by 1.04, that is gonna amount to roundly about $8652. Yeah, okay, this is, sorry, 1.05, which I made a mistake here. So it simply is going to be 8,000 times 1.05 into 1.05, which is gonna turn out to be $8820, which is nothing but my answer, option A. So suppose you're understanding what I'm trying to do here, guys. Pretty easy stuff. All you got to do is just got to balance the equation out. Alright, let's see this question here. Let's say the man says a man borrows $6,000 at 5% compound interest. If he repays $1,200 at the end of each year, find the amount outstanding at the beginning of the third year, right? So a man borrows $6,000 at 5% compound interest. So it's going to be 1.05, right? Find the amount outstanding at the beginning of the third year. So, this, and okay, fine. So if he repays $1,200 at the end of each year, find the amount that would be outstanding at the beginning of the third year, right? So this is what I gotta calculate. Gotta calculate the amount outstanding at the beginning of the third year. So let's suppose if we talk about the first year, that is going to be equal to $1,200. Yeah, the first $1,200 that he pays, that is gonna be at the end of the third year. So this is the first year. This is the 0th year. This is the end of the first year. This is the end of the second year, and this is the time when the third year starts as well. So this is gonna amount to 1.05, and this is gonna amount to simply 1,200, and this would be the amount which is paid. And the amount which has to be paid would be 6,000 into 1.05 square, because it's the beginning of the third year. That would mean the end of the second year, right? So at the end of the second year, there would be 2 years gone by, which is why this is what is going to come down to. So 6,000 into 1.05 square, it's going to come down to be equal to $6,615. So this is the amount that he was supposed to pay, and this is the amount that he has actually paid. which would be equal to 1200 into 1.05 plus 1200. That is going to be $2460. So what is the amount that is outstanding? That would be the total amount minus this. The amount outstanding would be 6615 minus 2460, which is going to be equal to 6615 minus 2400 is going to be equal to $4155, which is nothing but our answer, option B. So suppose you're understanding what I'm trying to say here. All you have to do, the only adjustment that you have to do is make sure that whatever installment you make, you adjust it for its interest. That is the only thing that you have to do. Fine. So this would be about the video, guys. Thank you very much for watching this video. Thank you very much for watching this video. And we have completed compound interest 2, wherein we have taken care of the installment parts, right? So these are the questions which you mostly encounter in CAT and other exams. Well, GRE and GMAT would test it again. You know, there is a chance that they might test it, but very rarely, very rarely, right? So this would be like a very minor topic that they want to put their hands on, right? So again, this would be the web address for exploring more about us. There's a lot of exciting stuff that is there. Then this would be the web Facebook page where you can give us your valuable like, and here you can give us your feedback. So this would be about the video, guys. Thank you very much for watching, and I'll see you in the next one.